Hi, so in this lecture I will be talking about composition. If you've already seen my inheritance PowerPoint lecture, this was actually the first slide on there as well. So the two common ways to relate two classes in a meaningful way in object-oriented programming are inheritance, which is the is-a relationship, and composition, which is the has-a relationship. So hopefully you've already seen my lecture on inheritance. If not, go ahead and take a look at that. I already have the lecture up for inheritance. But what I'm talking about in this lecture is, of course, about composition, which is the has-a relationship. So I've already mentioned in the previous inheritance video, but I'll mention it here again. In object-oriented programming, the beauty of having object-oriented programming and why object-oriented programming is so popular is because of the way it allows us to relate two classes together. And these are the two ways, inheritance and composition. So what that is basically part of code reuse. So if one class has already been created and you're doing a project that can make use of that class, but with some tweaks, you can either do an inheritance composition with that class, or an inheritance relationship with that class, or a composition relationship with that class, depending on the answer to the question, are these related in a is-a relationship or a has-a relationship? So it's basically a way of code reuse. So again, we're talking about composition, which uses the has-a relationship right now. So basically what's happening in a composition relationship is that one or more members of a class are objects of another class type. Composition is a has-a relation. Arguments to the constructor of a member object are specified in the heading part of the definition of the constructor. So let's take a look at an example. So every student has a course. So let's say you're creating a project and you realize that you want to create a class called student, and you also realize that you need to keep track of the courses that the student is taking in your program. So obviously we're actually dealing with a class called student and a class called course. Now if we wanted to do inheritance, this wouldn't really work because every student is a course does not make sense. Every course is a student also does not make sense. So this relationship fails the is-a question. So therefore, we can go ahead and try the other question, which is the has-a. Every student has a course. Well, yes, that makes sense. So this actually relationship passes the has-a question, and therefore this automatically tells us that the relationship we're looking at here between these two classes is, of course, composition. Okay, so we've just realized that someone else has already written a class called course, but we have to write our class called student. And so basically we're kind of reusing code. Someone else wrote a class called course. We're writing a class called student. We realized that we can make use of this class called course. We found that the relation between the two classes is a has-a relationship, so we're now ready to do a composition to set up these two classes to work together. Okay, so here's how composition works. So let's look at the course class. So someone else has already written this class, let's say. So here it is. So we have a class called course. Basically what this class has is a string private member variable called course name. It has two public functions, set course name, get course name, so just your typical accessor mutator. And then here is course.cpp. We basically just set course name, we take in a string and we set it to the private member variable course name. And then we have a get course name, which basically just returns course name. Okay, so someone else has already written this class. Now our job is to write the student class, but we realize that we want to keep track for a student their ID number and their course name. Now, it will be tedious to have to write set course name and get course name for the student class because we just realized someone has already written a class that has those things, set course name, get course name. And remember, we want to do code reuse because it saves us time. There's no need to rewrite these two functions when the two functions have already been written and the definitions already written. So all I have to do then is notice what I'm doing in the student class. I'm doing a composition. Composition basically means, and let me go back to my slide with the definition, one or more members of a class are objects of another class. Okay? Basically just means an object of one class is a member of another class. Alright, so with that in mind, let's take a look. Right, so notice right here in the student class, I have under the private accessor specifier in the student class a variable called ID that holds integers, and then right here I have an object called studCourse that is an object of the course class, which is right here. So that is basically what composition means. It's when one class has an object of another class as a member. So in this case, course studCourse is a member of the class student. So class student has an object of another class, in this case course, as a member of its class, and therefore this is called composition. So that's basically what composition means. So alright, so let's go down and take a look at the class student. So it has two private members. One is an integer variable, one is an object of course class. In the public header, I just have set course, set ID, get ID, and the print function. Okay, let's take a look at the definitions. In the student set course function definition, we're taking in a string variable called name, and then look what we're doing in the definition. In the definition, we're using the studCourse object of the course class and the dot operator, because remember, that's how you access any functions of a class, is by its object and the dot operator. So we just use studCourse dot, and then we call the set course name function that the class course already has, and we're passing in this variable to that function. So what does set course name do? And take a look. Whatever is passed to set course name is passed in, and it's set to the course name private data member of course. Okay. So in this case, we have a set course function in student, but the definition and the actual tasks are being done or being passed over to the course class through the course class's object that is a member of this class called student. So in set course for student, all we do is pass the name along to the set course name function of the course class through the course class's object studCourse. Then we have set ID. Of course, ID is a member of class student, so we just set the passed in value I to ID. We have get ID, which just returns ID. And then we have a print function. So in the print function, you'll notice all we do is say, okay, well, here's the student ID. We see out whatever data is in ID. And then we say the course name the student is taking is, and then we just use our object that's a member of the student class that is of the course class object, and then we just call the function get course name. And then of course get course name is a function in the course class which just returns the course name. So at this point, this will just return the course name for that student, and that will be, of course, because it's in the cout statement, will be printed to the screen. So here's what the main will look like. So here we have main.cpp, we included student.h. We don't have to include course.h because student.h includes course.h. Okay? So by including student.h in main, we are indirectly also including course.h. So here's our int main. All we do is we create an object of student. So in my case, I create an object called 1. And then we can just call functions in the student class. So here are all the functions that are in the student class. So in this case, I'm calling set course. I'm setting the course to CIS247C. And I'm setting the ID for the student object 1 as 1, 2, 3, 4, 5. And then I'm calling the print function from the student object. So when I pass or call the function called setCourse and I pass in CIS247C, what's happening is the setCourse function in the student class is going to be called, where CIS247 is passed in. The CIS247 is then passed into the setCourseName function from the StuCourse object that's a member of this class. And then so in the course class, the CIS247C is being set as course name. Okay? And then when I'm calling set ID, of course, that's going straight to here, and then the I that I'm passing in, which is 1, 2, 3, 4, 5, is being set as ID. And then when I'm calling print, basically the print function is being called, in which case student ID is printed to the screen, followed by course name taking is, and then in this case, get course name is going to be invoked, where course name is going to be returned and then outputted to the screen and cout. Okay, so basically, when you have a composition, it just means that you have an object of a class, of another class, as a member of one class. So here I have StuCourse, which is an object of the course class, as a member of the class student. Well, now notice in my example I don't have any constructors. So what would the constructors look like if I had a composition relationship? Parameterized constructor. Let's assume that in course.h we had a parameterized constructor called course that takes in a string argument. And here's a definition of the parameterized constructor. Takes in a string, sets the string to the private member variable course name. Now, how would that work if I was in the student class and I'm using a course object in the student class? How do I use the parameterized constructor? Well, here it is. So let's assume we have a student constructor in the student class that takes in a string and an integer, the string for the course name, integer for the student's ID. Well, here's how the parameterized constructor's function definition would look like. The student constructor takes in a string C and an int I. However, it doesn't have a string C for course name here. It actually passes in the C using the course object StuCourse. And then the I is then set to ID. And then in int main, all we have to do is just create an object of the student class, pass in the course name, pass in the ID. All right, thank you very much.